In this video, we're going to be looking at a practice set that has multiple levels of independent variables. So up to this point, we have looked at data that is just dependent variables that were collected for every single person, and those subjects weren't categorized in any specific way. When we have leveled or categorized or nominal data that is splitting our subject count or our total sample size into different groups, we have to investigate normality within those groups, separate from each other. So we're going to look at normality using a split file command that allows us to split our groups when we run certain analyses. And then I also wanted to go back and show you guys the means analysis and just how to input data if you were wanting to perform different descriptive statistic calculations when you have certain dependent variables and a leveled or a factored independent variable. I've added some tips on the bottom on different selections that you can make with each test, but we'll move over to our data and we'll get started. In this spreadsheet, you can see there's a legend on the side, and this is kind of our first cross with nominal data, actually visualizing it. I have people listed by sex, so females have been assigned a data label of 1, and males have been assigned a data label of 2, so that's pretty much the rest of the data in the spreadsheet. I also have different sports that have been collected, so soccer has a data label of 1. Right? If I pair my sex and sport labels together, these would be female soccer players compared to male soccer players, right? 2 being male, 1 being for soccer. And then also I have basketball, swimming, and lacrosse players as well. And we collected mile time, push-ups, and plank time for all of these individuals. First things first, let's copy this into SPSS. So I'm going to highlight all of my data, including data labels, and I'm going to copy it. And then when we open our SPSS data window, I would recommend saving each of your data sets. So the way that you can do that is to either click on this Save button, and then you can title it and indicate where in your computer you want to save the file. I recommend saving to desktop, or if you have a documents folder or a hard drive that's designated for this class, I would save it in there. But in the later data sets, this one was pretty easy to set up, but ones that actually take a little bit more work, you're going to be sad if you messed up a test and you didn't save your data set and you have to go back and re-edit everything. So I would save them instead of deleting them. But what we can do right now is we want to create a new data set. So you'll click on File, go to New, and then click Data. This will open up a blank data set, so we can minimize our other one. And then we can paste our data with variable names. We then want to go to Variable View, and we're going to alter our sex and sport data. 1, these are nominal data because they are categorizing our subjects based on certain characteristics. And the rest of our data is scale or ratio. The other thing that we are going to edit for sex and sport is identifying what the values mean in these columns. So if you recall, if you click on, I don't know, that might have been too quick, but this little this 3-dot box here, if you click on that, you can insert and identify a label with a particular value. So 1 for sex was representative of females, 2 was representative of males. You can click OK, and then we'll do the same thing for sport, which 1 was soccer, 2 was basketball, 3 was swimming, and 4 was lacrosse. And then we click OK. And now we've identified that these values, if we go back to data view, these values in these rows are not actual numerical values that we want to incorporate into statistical calculations. Rather, they are labeling our subjects to meet a certain characteristic. So from here, we can run a split file command. And the way that we do that is we go to Data, or we can click on this icon. So you see the little text pop up as split file. So we can go to that, or we can do Data and split file. Access either way. When this pops up, you can either click Compare Groups or Organize Output by Groups. I personally like the Compare Groups option better, but I'm sure there are times when organizing the output by groups would also be helpful. This is actually one of the helpful tips that I commented on in the instructions document. Compare groups, when we run an output, what you usually see is that you've got like your histograms and your box plots. Each of those chart types or your descriptive statistics run in a certain order. And if you do compare groups, your output will run in the exact same order. It will just list group by group by group. So if you're looking or dividing your individuals by sex, and we wanted to look at differences between mile times, you would have female mile time, then male mile time, in whatever descriptive statistics or plot that you're looking at. If you organize output by groups, what it will do is it will clump all of the female mile time data, so plots, descriptive statistics, etc. It'll put all of those in one chunk, and then you'll get all of the male ones after that. So I'm going to do compare groups, and let's say we want to split our file by sex. We can press OK. It'll log that we're splitting our file in the output. And then what we can do from here is analyze our data. Let's do a frequencies analysis. And let's say we wanted to look at push-ups. Honestly, you can choose any variable you want. I'm going to uncheck the frequency table box. And for statistics, let's do all of it. If we wanted to make charts, we could add those. But I can press OK and it'll add it to my output. And you'll see what I mean in terms of how it's organized. So I'm going to label this practice 3. You can see now it helps because we've now run 2 frequencies analyses, and if this said frequencies and this said frequencies, it can get confusing on where you look at stuff. So this is what would show up when we have a compare groups, right? So all of our statistics are lumped together, all of our histograms are lumped together. But we can look at all of these calculations for males separated, or females separated from males. We can see what each sample size is, etc. So that's kind of cool. And then we can also view our frequency distributions with our samples split from each other. So we have our female push-ups. We can assess that that data is fairly normally distributed just based on how it fits the curve. Male push-ups also kind of looks normally distributed. There might be some issues in here, but we can look further into that if we looked at our skewness and kurtosis values. So if we divided our statistic from our error for both of these, then we could figure out if there was an issue in terms of z-scores for skewness and kurtosis and how they align with what would be expected of a normal distribution. If we wanted to assess normality further with the Shapiro-Wilks test, we could click Analyze and go to Explore, where we just did push-ups, so we could put push-ups in our dependent variable area, sex in our factor list. Again, we don't really need to do anything with statistics. If we wanted to add any of these, we could. We already plotted a histogram, so I'm gonna skip that. That would add down to our output. There it is. So I'll say practice 3, explore, and this one was our frequencies analysis. So then we see the same descriptives, right, just organized a little bit differently. We have a box plot showing that there's a subject 12 is an outlier in our female distribution. For males, no outliers, but you can see that the middle 50th percentile, not 50th, the middle 50% of our distribution, this is quite a bit larger than the female box. The one thing that I forgot to click when I did this analysis was normality plots with tests. I wanted to show you guys the Shapiro-Wilks test, so this is going to run again. We're going to get copies of what we've already got in here. But actually, I'm kind of glad I messed up, because then I can show you how to get rid of things that you don't want in your output. So if you ever mess up, like I just did, okay, you can see this is a lot longer. This has everything that I want in it. But I messed up on this one. What you can do is you can click on this yellow notebook icon, go to Edit, and then Delete. And that will take it out. You can also delete the log associated with the particular test. But now we can go to our test of normality, where we've got our Shapiro-Wilks test, and then we can see our females normally distributed and our males normally distributed. In this case, both of them are. If we look at our QQ plots, right, females are fairly aligned with our model, our linear model. QQ plot for males is a little less so. You see more deviation of the dots from the linear model. And then our box plots are at the bottom. So basically the same thing that we already got in the first run through. So that's using a split file, where automatically we'll separate your data. If we wanted to do this for sports and separate soccer from basketball, from lacrosse and swimming, we could see if when we separate our data by sport, are each of our sports normally distributed, in addition to our sexes being normally distributed. The other thing I wanted to show you guys was the means analysis. So we go to Analyze, Compare Means, and then now we can say, oh, if I want to separate people by sex, and let's do Planck time for our dependent variable. Okay. Now we can say I want to look at certain descriptive statistics, which I would choose in my options area. Right? So any of these calculations I can then find for different sexes based on plank time. Which I think, again, it's just kind of another way to get, where is it? This table. You would basically get the exact same calculations. So frequencies analysis, explore analysis, and your means analysis will give you all of your descriptive calculations that you want. What is different between all of them is that frequencies analysis does not split your people up, or it does not split your independent variable groups up unless you combine it with a split command. Your explore function can work without a split command, but if you have it turned on, it's not going to change anything except for maybe how your output is organized. And the means analysis is different from the frequencies analysis with the respect that you can, or it's more tailored to if you have independent variables with multiple levels and you want to categorize your people by those levels. But you can also do the exact same calculations, if not more, with an explore analysis. So I'll leave it up to you guys which ones you want to do. I would recommend messing around with all three, just so you know, like the pathways to get to what you're looking for, etc. In the previous video, I noted that you can also create graphs in SPSS when you have various groups that you might want to compare to each other. To do this, we can go to Graphs and the Chart Builder. I can see my variables are inserted over here. And let's do an example of a box plot. Now, in the first, or practice 2 video, we made a simple box plot because we only had one variable or one group of data. When you have multiple groups of data, you can use a clustered box plot. So we'll drag that into here. The x-axis is the categories or the grouping that you're interested in comparing. So let's say we wanted to compare males versus females. We could drag sex into this x-axis box, and now we can see there's an area for females and an area for males. The y-axis will be the variable that we are interested in looking at the measurement of, so maybe we want to compare push-ups between males and females. This top box over here is basically your legend. So if we were only interested in comparing sexes, we could stick that over here. And then in the chart appearance section, that's where we can change the colors of our categories. So category 1 we can see is blue. Category 2, maybe we want to be green. Sure. It's kind of up to you. That's more of a personal thing, right? And then let's click OK and see what shows up. So now we have blue as female, green as male. They are in their respective categories. If I wanted to change the spacing of this, I can always double click on the graph. And then if I wanted to change my y-axis values so that we had expanded boxes or whatever, I can always double click on that y-axis, go to scale, and then change the minimums and maximums or the level by which they increase. I think this looks fine, so I'm going to keep it as is. Now, if we wanted to add an additional layering, so because we have our individuals collected both by sex and by the sport they played, we can add an additional layer. Instead of putting sex up in the legend area, we could replace it with sport. So in this chart down here, what we then end up seeing is female soccer, basketball, swimming, and lacrosse teams, and male soccer, basketball, swimming, and lacrosse teams, and how push-ups compared across each of those different groups. Again, we still note the outliers that might potentially exist in non-normal data sets. We could alternatively change this, so let's say instead of sex being on the bottom, we wanted to compare the sexes within the various sports. So in that case, sport would be our category, and then our different variables or different clusters would be based on males versus females. So that's what that graph would look like, right? Soccer, basketball, swimming, lacrosse, females are in blue, males are in green. Okay, so those are some examples of how you can create charts based on grouping factors.